Okay guys, so we're going to continue with solving equations today. The equations that we solve are going to look slightly different to those that we solved in the last lesson. Just to start off though, could you pause the video and just have a go at solving that equation? But I want you to solve it formally, okay? I don't want you to just think, oh, we do the opposite, you know, that's how we did it in primary school. That's not important here. What is important is that you develop this method that you can use fluently to solve any equation. So pause the video now please and have a go at that. Okay guys, the solution's here. Okay, and we've done everything properly. We've realised we need to isolate the unknowns, so we've subtracted 4 from both sides, which I've just shown here. I've then done it, okay, tidied it all up to get 3x equals 15. We don't want to know what 3x is, we want to know what 1x is. So we divide both sides by 3. We get 3x divided by 3 is x, 15 divided by 3 is 5. They are similar to what you practiced the other day, okay? So we're going to look and remember that an equation will always remain equal as long as you do exactly the same thing to both sides of that equation. So here, okay, we've got 3x plus 4 is equal to 19, which we know the solution to, x equals 5. I've added x to both sides of the equation, so I get 3x plus 4 plus x, and 19 plus x. I've tidied it up, and I've created another equation. 4x plus 4 is equal to 19 plus x. I've added x to both sides, so they are still equal to each other, okay? And again, if we add 2x to both sides, okay, if I add 2x to this side, I must add 2x to this side, otherwise this equals sign is irrelevant, okay? And I do that, and then I tidy it up. We end up with a third equation here, 6x plus 4 is equal to 19 plus 3x. Now, we are going to look at solving these types of equations. So 4x plus 4 is equal to 19 plus x, and 6x plus 4 is equal to 19 plus 3x. Obviously there are unknowns on both sides of the equations, which makes them different from the last lesson when we looked at equations with unknowns on only one side. Now, you've seen that we can add unknowns to both sides of the equation, which means that in reverse we can subtract unknowns from both sides of the equation as well. So if we were to move backwards, if we took away an x from both sides of this equation, we'd get back to this, okay? And we're going to look at how that's going to help us solve it. So if I just move this out of the way. So we've got that equation that we created, 4x plus 4 is equal to 19 plus x. The solution is going to be x equals 5 because it's the same equation that we looked at for the starter, but just manipulated a little bit. So firstly, I'm going to show you what it would look like as a bar model, okay? So we'd have 4 x's and 4 on one bar, we'd have a single x and 19 on the other bar. Now it's really important the way that we line these up, okay? Now it's just a rough guide, this diagram, but we know that on both sides of the equation x must have the same value, so on both bars x must have the same value. So it's really important to line up your unknowns so that you can see that they're going to be the same size as each other regardless of what bar they're in. Now, we want to isolate our unknowns. To do that, we need to make sure there's unknowns in only one bar, or one side of the equation. So we could take an x from this bar, and we can also take an x from this bar, and as long as we do the same thing to both bars, then it's still going to be equal, they're still going to be the same size, and we are not going to have kind of broken that equal sign. So we end up with 19 is equal to 3x plus 4, which is an equation that we looked at solving at the previous lesson. And as I said, that would mean that 3x must equal 15 if we get rid of 4 from both sides of from both bars, and 3x's are equal to 15, which means 1x must be 5. Now looking at that formally, okay, I'll cover it up as to not kind of overwhelm you with loads of numbers, letters, symbols and so on. But we start off with our equation. We recognise that there are unknowns on this side of the equation and on this side of the equation. We're not going to be able to isolate them if they're on different sides. Now, I'm going to choose to deal with this. and I'm going to say, well, I'm going to subtract x from this side of the equation to deal with that. I'm also going to have to subtract x from this side of the equation, otherwise it's no longer equal. This is what we get, and then we tidy it up and we end up with 3x plus 4 is equal to 19, and the rest of this we looked at during the starter. Okay, from this point down it's exactly the same equation that we looked at the start of the video, so if you're unsure about any of this, restart this video and look at what we go through. Okay, so we also made another equation. Okay, we also made 6x plus 4 is equal to 19 plus 3x. Okay, so I've drawn this as a bar model. So we've got 6x plus 4 is on the top bar, and we've got 3x plus 19 is on the bottom bar, or 19 plus 3x. Remember, it's an addition, it doesn't matter which way round it goes, they are commutative. So, again, I've made sure that I've got exactly the same sized unknowns in both bars, and I've lined them up, because it's going to make it easy to see what we need to do to be able to solve it. We've got unknowns on both bars. We only want there to be unknowns in one bar. We could get rid of all 3 of these unknowns, but we'd have to get rid of 3 of these unknowns as well, which would leave us with 3x's and 4 is equal to 19. Solve as we did last lesson. Okay, literally the same equation that we've just looked at. Okay, it just started off looking a little bit different. Now, again, we've done this formally. Okay, so if I just move this forward a bit, so we've got 6x plus 4 is equal to 19 plus 3x. Unknowns on both sides of the equation. This is an issue if we want to solve it, because we need to isolate the unknowns. We can't do that if they're on different sides of the equation. So, I'm going to deal with this. I'm going to take away 3x from both sides of my equation. Okay, if I take away 3x from this side of the equation, I must do it to that side of the equation. So I've done that, and this is what it tidies up to. Okay, and again, I'm not going to solve that equation because that's the same equation that we solved in the starter. X will equal 5. If you're not sure how to get from there to x equals 5, again, go back to the start of this video and it will show you. Okay, so one last thing I want us to look at, okay, is every time we answered those questions, I took a specific amount of x from one side to the other. I always took the smallest amount of x away from both sides of the equation. Now, does it matter? Should I take this 1x away from both sides, or can I take 2x away from both sides? Okay, and I'm about to show you what happens if you did it 2 different ways. So if we looked at method 1, okay, so I'll just show method 1 for now, okay. You've got 2x plus 10 equals x plus 6. I'm going to get rid of x from this side of the equation to remove that, but I must do it to this side of the equation as well, otherwise it's not equal. This is what we end up with, and this is it tidied up. X plus 10 is equal to 6. Take 10 from both sides, we end up with this. X plus 10 take 10 is x. 6 take 10 is negative 4. So x must equal negative 4. Now if we look at it on the second way, if we decide to take 2x from both sides, we're going to end up with something that looks like this. 2x plus 10 take 2x is just 10. X plus 6 take 2x is going to be 6 take away x, or negative 1x plus 6. Either way round is fine. I still need to isolate my unknowns, so I'm going to subtract this positive. I'm going to subtract 6 away from this positive 6, but I must also subtract 6 away from this side of the equation as well. So we get 6 take x take 6, and 10 take 6, which means that negative x is equal to 4. Well, if 4 is equal to negative x, then negative 4 must be equal to x. And I wanted to show you that, guys, because although it doesn't matter which side of the equation you try and remove the unknowns from, there is normally an easier way of doing it, okay? And I find that this way of dealing with the smallest amount of the unknown leaves you with an easier equation to solve, because it means that you're not going to end up with a negative amount of unknowns on any side of your equation, whereas on this one we end up with negative x. Okay, and that creates just an extra layer of difficulty that we don't need. Right guys, could you please now have a go at the questions put on the show my homework assignment, okay, on the Word document for me? Thank you.